Welcome to a brand new weekly podcast called Weather Legends. I'm meteorologist Rich Von Olin, and I'll be your host. These are the true veterans of meteorology across the metro New York City region, the names, faces, and voices of those many have come to know for decades. We've got Joe Chaffee, one of the original News 12 meteorologists whose TV career began way back in the 80s. Joe Rayo, another former News 12 meteorologist who will also bring his extensive knowledge of astronomy to our podcasts. We've got Bill Corbell, a weather icon in the New York metropolitan area, a longtime radio and TV broadcaster. Bill recently retired after 25 years at News 12 Long Island. And Pat Pagano, a forecaster and broadcaster for decades here across the area, and still at it. And finally, James Gregorio, who will join us now and then, yet another longtime News 12 meteorologist, mainly for our neighbors over in New Jersey. These are the meteorologists whose careers have spanned the decades, from paper charts and crude computer forecasts to today's supercomputers, satellite images, and Doppler radar, before weather technology became what it is today, and before social media. I welcome you to listen to our stories and experiences throughout the years. I think you'll find the insights to be rather unique and very informative. So be sure to join us for Weather Legends. Hey everyone, welcome back to Weather Legends. Today we have got Bill Corbell with us and Pat Pagano with us. And thanks for joining us today. And it's going to be a pretty good discussion. We're going to be talking about old school weather forecasting and tools versus technology today and how it's evolved throughout the years. And we've seen a lot of changes in the many years we've been in the industry. So I guess maybe Bill, we'll start with you. What have you seen change over the years? We have some cool graphics to show too.
Yeah. Start with me because I'm the oldest one here. I remember when we used to do it with a crystal ball. That was it. That was the highlight of our abilities. That's the way it looked back then. Anyway, you know what you have to remember though is that every year in the past was the state of the art. And once upon a time, when we didn't have everything done for us, as it almost is now, we actually, people are going to find this hard to believe, had to plot weather maps. Oh my gosh, what a concept. Mm-hmm. You'd have a blank map of maybe a local area or the US. You would tear off the teletype, the airport observations, the essays, the airport observations, and plot the pressure, the winds, the temperature, the type of weather, and the pressure tendency for each of those spots. Then you would analyze it. You would draw the pressure lines, equal lines of pressure, isobars, and eventually you get a weather map with highs and lows and fronts and things of that nature. Now, of course, you just click on an image and there it is. But what this made you do was really look at the weather, because as you plotted each of these maybe 50 or 100 weather stations, the information sunk in. Rather than looking at a big blurry picture, you got the details, and that helped. And I might add one other way we did things way back when. We in the Air Force, we called it pencil progging. Okay, computers were just barely coming in. They were not very good. In fact, they were almost useless for anything but upper level winds, which we used them for. So what we'd analyze a chart, or take it off the facsimile machine, because the National Weather Service would send out charts analyzed with fronts. See where the front was, maybe 6 hours later, see where the front was, and measure the distance it traveled in 6 hours. And see if it travels that same distance in the next 6 hours. And if it does, you know the speed it's moving, and you can forecast when it's going to get to you. Pretty crude, but you know what? It worked, and it still works today, and you guys may agree. Let's say there's snow spreading up the coast, and if you plot where the snow is at time X without even looking at radar, and then a couple hours later, plot again and see how far it's moved. Do that for a few hours. You get a concept of how quickly it's moving and when it's going to get to you. And you combine that with radar data and you get a better idea of when it's all going to start.
I'd agree with you more, Bill. Yeah. Captain Frank Quinn, he was in charge of United Airlines. This goes back when I first started. Yeah. And I used to go to LaGuardia Airport where he was to pick up the maps, the DIFAX maps, or Navy. Yeah. Well, yeah, the DIFAX maps. And he said to me just what Bill said. He said, your most important thing, he said, as you get into weather forecasting, is to watch your observations from 1 hour to the next. That will be the more important key as compared to looking at any of these progs. And, I used to teach everyone that came into my service the same thing. That is very, very important. And, I tried to remember, I know, Rich, you're younger than both Bill and I, so you may not remember this, but initially, the first computer model that I remember was the barotropic that was only available through 36 hours. Then the baroclinic was available to 48.
Wow.
Then we had the aviation. Now that was available, that model, through 48 hours, but you had the 60, 72, and 84 500 that you could try to extrapolate to get out through 84 hours. And then we came up with the LFM through 48 hours, the NAM through 48 hours, and then the GFS. And of course, now we're with the Euro. But I thought, what was the grid space on that first model?
Look at the difference. Look at the LFM to the rapid refresh, for instance.
80 miles was the grid space on the initial model, all the way, as Bill said, through the LFM. And now you have what? The GFS is at 8 miles for the grid space, very localized. And the Euro is at 5.5 miles.
So, and the rapid refresh, I think, is down to about 2 miles.
Isn't that incredible?
Yeah. And what people explain what it is you're forecasting for a point within this square, and that square was huge once upon a time. So if you have just 1 point forecast, it misses a lot around it. The smaller you get that forecast square, the more precise the forecast can be. And now you're getting to the point where, again, the rapid refresh model, which we may talk about another time, can almost pick out individual thunderstorms, for instance, at least if they're big enough, which is phenomenal. And it's updated for every hour, mainly for aviation. I use that when I fly because it's almost like a future cast of radar. And for, aviation, most forecasts really are within 6 hours, most flights. So it's a short-term thing. It's totally different than looking, 10 days ahead of the weather.
Yeah, when I came online, the first models we had were the LFM, the NGM. We had the AVN model, the aviation, and we just plotted, like you said. We still had the maps, the DIFAX coming out, the purple ink you got all over your fingers, the cutters. You had to be careful, and you'd put the maps on the wall and you'd stack them over and over again, similar to what you see in these pictures here. When we're in the map rooms. And this is what it was all about back then. We didn't have the supercomputers. We didn't have things at our fingertips to make it so fast and easy. I think the other thing too is that it took a while to analyze, because number one, you had to wait for the stuff to come off the teletype, the faxes. Then you had to rip them off, and then you had to take your pens, your pencils, and look at them and go over everything. And that's where, it became kind of crazy. And, this is what it was all about back in the day. Even when I went to college at SUNY Albany, we had, 5, 10, 15 meteorologists there, all analyzing and looking at these maps. But I guess the question to you, Pat and Bill, is, the resolution, I guess, has gotten better, but have the forecasts gotten better?
Oh, yeah.
And what was the goal? What was the strategy back in the day? I guess I'll go to you, Pat, because you did a lot of radio and you had to look at stuff. I mean, what did you have to go by, your instincts, when you were looking at these maps and you didn't have the high resolution stuff at your fingertips?
Bill was showing us a book that he had in his possession, which goes back and looks at all of the big winter storms. A lot, I remember, I would always go back and research and see if I can get some sort of an analog for the current weather situation and what happened back then. And again, a lot, as Bill said, up here, because when you plotted and you timed everything out, all of that just stays in the back of your mind. And when you see a situation that's kind of similar, you remember back, this is what happened then. Not saying that it will happen identically, because no two weather situations are alike. In all my years, I mean, we've had similar situations, but they're not alike. But in radio, as Bill knows, you have to update a lot more than you do in TV. Although now TV, breaks in every 3 minutes. if we have a big event. But back then, you just had to wait for the TV news. So there was a lot of pressure and stress. And I do remember times where the machines would break down and you didn't have the maps. So that's where the plotting comes in. And you just had to sit down and know your stuff, plot, and let's get going.
Yeah, but look at the difference now. I happened to, before we got together, looked at the errors for National Hurricane Center forecasts. And this shows you the improvement. Back in, let's see, 1980, okay, the 72-hour forecast for hurricanes was off by 400 nautical miles. The 24-hour forecast by 130 nautical miles. That means instead of hitting New York City, it would hit Virginia.
Right.
That's 24 hours. Now, our 72-hour forecast error is only 75 miles, and 24-hour forecast area for the center of the storm, 30 nautical miles.
That's incredible. Yeah.
So that's what computers have done. That's what the current observation systems have done with satellites and radar and hurricane reconnaissance, which is done by the Air Force and NOAA. All that has brought that 24-hour error down to 30 miles and 75 miles for 72 hours, where it had been 120 miles. So that's crazy.
So now, Bill and Chris, people say, mainly in the wintertime, how come you guys can't nail a snowstorm? I mean, here we are talking about the great improvement. How come we can't nail a snowstorm? I'm not going to answer that. Go ahead, Bill. You answer it.
Okay. It has to do with the complexity of the atmosphere that we're dealing with and the Earth-atmosphere interactions. The Earth varies. You have water, you have land, you have deserts, you have mountains, you have tree-covered lands, you have cities. The atmosphere is always moving. And this interaction is extremely complicated, so much so that even our current computers cannot grasp all of the intricacies. We've come a long way. And then think about snow. To predict the amount of snow, you have to know the intensity, how much water equivalent there is, and how that equates by temperature, the amount of snow that will actually accumulate. Nowadays, since people measure it endlessly and put it up on the internet, you have to also try to consider how much will it compact. If it's a big storm, you may measure every hour 1 inch, and after 12 hours have a foot. But if you don't measure it every hour and you stick the rule in at 12 hours, it may only show 8 inches. So there are a lot of variations. But here, Pat and Rich, Long Island is tough. That ocean is a huge influence. You have to get just the right wind direction to make it all snow here.
Mm-hmm.
But again, I think the forecasts have become very, very good. But don't expect it to be exactly 8 inches in your backyard. Plus the observations we get. I know for a fact that, a lot of people just stick a ruler in the ground. If I put it in my grass, 1 inch of snow is going to show 3 inches. You have to measure it correctly. But the forecasts have gotten so much better. Once upon a time, you watch TV when I was a kid and they'd say, heavy snow tomorrow. Mm-hmm. That's it. Not how much. Just, it's going to be heavy snow tomorrow.
Yeah. And what I've heard a lot, it's been driving me crazy in recent years, is that people will say, the forecast was so much more accurate back in the day. And I think what they're alluding to is that I think number one, you have apps, which I think are problematic in many ways because they don't tell the whole story. And I think there's an expectation based upon the data that we have that things can and should be more perfect for your backyard, which I think is also tough to, kind of get across to people, And I think the other thing is that the frequency, you're so over flooded with so many forecasts nowadays that it's confusing. You can look at so many different things. Like Pat, back in the day, what did we have back in the day in terms of TV and radio? You go all the way back to the days of Tex Antoine. Like, explain how many TV and media outlets there were back then that gave you weather.
It was just the main stations, 2, 4, 5, 7, 9, and 11, and not all of them had meteorologists. So you didn't have a tremendous amount of forecasts circulating. You had the National Weather Service and a couple of other private forecasters circulating, which made it better. But, we brought this point out a little bit earlier. We give ranges, all of us, right? 6 to 10, 8 to 12. And, you'll meet somebody on the elevator said, I heard Pat this morning on WALK. He said 12. No, I didn't. 8 to 12.
Exactly.
They immediately drop that and go for the big number. And then, of course, they get 8 inches. Well, we were wrong.
Yeah. Oh, the other thing is the new visually on TV, you put on a forecast from a computer that will show snow amounts to the 10th of an inch.
Right. Yeah.
This is absurd, but that's how the computer spits it out.
Right.
It should be rounded up. In fact, my view of computer forecast is that there's no way a forecast out 10 days should look as precise and as intricate as one out for 24 hours. As you go out, it should become blurrier and blurrier and blurrier. My analogy is you're driving across Nebraska towards Colorado, right? Initially, you don't see anything. Then you see a little blue haze on the horizon. What is that? I don't know. Get a little closer. Oh, it looks like mountains. Get a little closer. You see, yeah, definitely mountain. Oh, look, there's snow on the top. Get a little closer. You get the individual trees. That's the way it is forecast. The closer you are to the initiation, the clearer the picture should be. Out 4 days, 5 days, 6, 7 days, it should not be as detailed as it is just for 12 hours.
Agree.
Yeah. And Bill, you mentioned something about satellite technology and what's been launched into outer space over the decades. And I guess we basically started way back in the day with if I can pop this up here.
If you can pop it up, that was Tyros. Back when even I was a kid.
Oh, let me get the first one. There we go. There's the
now
first
look at
one.
that. This was a satellite orbiting the Earth. I think it was in polar orbit. I'm not sure. That was the satellite image. If you look carefully, right in the middle, kind of right there, it is right center is that's Nova Scotia, a little bit of Maine. What did that tell us? Not a heck of a lot, but it was the first step in what has become an amazing source. Go up to the current GOES satellite.
Look at the difference. Yeah, look at the difference.
This one you can zoom in and literally see individual cumulus clouds if they're big enough.
Yeah.
That's what you can see. And it's not just this is a visual picture. And someday maybe we'll talk about satellites and all the capabilities and how you can at home, if you're a weather hobbyist, really analyze different things than just looking at the visible picture. But that is huge. And think of satellites for discovering hurricanes and tropical storms out in the Atlantic, where once upon a time, the only way you knew that was out there is if a sailing ship ran into it. If it survived, maybe they said, hey, there was a storm out here. So yeah, huge difference.
And it pales in comparison. It's amazing how, when you look at some of the data that we have today that perhaps, we don't exactly appreciate. When the iPhones came out and the BlackBerries and all of a sudden, I used to go on the old NSEP, site, and, it was okay. It was pretty good. And now you've got these private companies like Tropical Tidbits, Pivotal Weather, and this is available to every hobbyist, everybody on the planet. And if you look look at this image, everybody goes here kind of who's a meteorologist, basically. You get detail in the analysis, and look at the right side, 384 hours out. When was that ever even thought of, Pat, back in the 70s, 80s? You even think about the forecast going back that far. What did you do? Did you even forecast? What was your range?
Oh, no.
3 days.
84 hours, pretty much. With the aviation was about the most we would go out. I think Bill could tell me whether or not I'm correct, but I think eventually the aviation did go out to 120 hours. Am I right, Bill?
It may have, but again, for aviation forecasts, really all that matters is the next 12 or so, 12 to 24. One thing I do to this day, I will. Let's say I'm flying. Okay, I'm a pilot. I'm flying next Friday, or a week from today. I'll look at the computer forecast for 7 days out,
right?
And I'll save that image. Okay, put it aside. I'll look at it every day and just see if there's a consistency. If that low is all of a sudden 500 miles in a different spot and then it's back again, then I'll know the computers don't have a good grasp on things. That way you can narrow it down, and as you get into the short term, again, 6 to 12 hours for aviation, you really have it nailed.
Well, this past Monday, the GFS was forecasting 20 inches of snow.
Wow. Yeah.
Was it really? I wasn't looking.
Yeah.
And then Tuesday, it was down to 4 inches, and by Wednesday,
there you go.
It was out.
There you go.
Yeah, it's amazing. And Bill, we talk about in concurrence, with the map I just showed you. I don't know where you came up with this, Bill, but this was a fascinating map here, the Plinko thing.
This is great. This was
Explain
done
it.
by National Weather Service in Kansas City.
Yeah.
And it's and you can blow up your screen perhaps, but it's a great example of how it's almost like the butterfly effect on a short-term basis. Your first forecast, and for these computer forecasts are done in steps. I don't know what the steps are now. Maybe they'll forecast out an hour, reforecast for the next hour, and it keeps on going. If there's one little error in there, it can mean that ball drops to a different route. And conceivably, if there are enough errors, you don't know what you're going to get at the end of day 9. Will it be no snow, or will it be 12 inches of snow? So that's it. Little errors can be magnified because they're incorporated into the system. Although now more and more, the computers are able to discard what seem to be errors, but still in distance, you're not going to get the accuracy you have short term. I can forecast precisely for the next minute. Absolutely everything, except maybe some leaves falling outside.
Yeah. And that's the funny thing we've been talking about, is that a lot of hobbyists, a lot of people online will see a map 300 to 324 hours down the road, like Pat mentioned. It's like a big blizzard, and they'll post that up on social media, and people go, "Wow, we're going to get a snowstorm in 2 weeks." Oh, come on, and this is what I'm saying. While technology is wonderful and we have this ability to see things, it's still, like Bill said, it's still subject to changes and more of an art of understanding what the reality is in these forecasts based upon the history of what we've seen throughout our careers, right?
Yeah. The longest I went in TV was 7 days out. It used to be, when I started, it was 5 days, I think. We do a 5-day forecast and leave it up there. Yeah. Then it went to 7. Now it's 10, and it's up for 10 seconds. What is it going to be? Boom, gone. So, how far do you want to stretch this out? But everybody has to keep going in that direction, because station A did it. Station B is doing it. We got to do 10 days. Let's do 12 days. Let's do a month. We'll put 30 days up there.
Yeah.
Go to Farmer's Almanac and do it. Get Joe Rayo here to help us do that.
Yeah. Well, speaking of which, like I said, experience does have its advantages. There are a lot of meteorologists across the nation, for that matter, in the world, who have been doing this, like you and Pat, for almost 50 years, half a century. And experience, it speaks for a lot. You look at what Tom Brady did, for many years in football. Yeah. And he won Super Bowls at age, why did he win? Because he had experience.
Yeah. And he's made a lot more money than Bill and I.
Just a bit.
Yeah.
I scratched my head on that. I said, why you want to hire this 41, 42-year-old guy who was in football, but he won he went to the Super Bowl.
Because when he got the line of scrimmage, Rich, he looked around, he knew exactly what the defense was doing, exactly what the alternatives were.
And it's an amazing
skill. The best rookie quarterback doesn't get that initially, although the guy down in Washington did pretty good this year.
Yeah. And speaking of rookies, I wanted to just pull this map up. Pat's been sending me a wonderful array of black and white photos back.
Yeah, name the people, Pat.
So I don't even know who. Yeah, Pat, why don't you go ahead and tell me who we're looking at here in this map discussion among you?
The far left is me with the mustache, and on the far right is Craig Allen, formerly of
unbelievable.
CBS
he was skinny.
CBS TV.
Everybody was skinny back then.
Yeah, you noticed, right? The gentleman in the middle, standing in the back, Kevin Williams, he went on to do TV, I think, in Rochester.
Yeah, that name's familiar.
Up there. And the gentleman kneeling down on the right, Barry Grossman, he went into forensic meteorology, and I believe he still has his own weather service on Long Island that caters to forensic meteorology, to the legal and insurance people. But yeah, I mean, back then it was a nice group of people, and you could see, as Bill mentioned, tons of maps, and we would keep the maps at least for a week, so that we can go back and we could look and see how accurate they were. Now today, like Bill said, all you do is press a button and you can compare it to one run, to the previous run, and it's all at your fingertips.
Yeah, but having that experience, because I was one of those. I was, that was a little before my time when I went to SUNY Albany. But back then we did the same thing. We continued this aspect of getting together, the whole gaggle of meteorologists, the geeks, putting the maps up, looking at the maps, analyzing, joking about stuff, and talking about the forecast. And in some ways, Bill, competing, who could get this forecast right, and that I think that's what made us great, because we talked about it. I think a lot of what happens today is that it's so numerical, it's so processed, it's so technological, and so much on the phones now. I don't think we have enough map discussion about what's going on that we used to have. And I think it takes a little bit away from what the messaging is, like you said, Pat, about what the people actually hear. And I think that's where the disconnect sometimes comes in. It's almost like too much information. It's too good of, too much of a good thing with technology. But I guess I'll leave you with the final thoughts. Bill, I mean, do you think there is too much technology? Is there a pro and con on it these days? What's the benefits and pros and cons of it?
It still comes down to communication when you're dealing with many things, including weather. How can you transcribe the incomprehensible technical complexities of weather into something people understand? And that's a difficult thing. And I think starting in radio, as I and Pat did, made it easier because we had to verbally explain what was going on. So, that's the problem. Communication, just looking at cold, hard data doesn't translate to the average person walking around, but that's what we've learned to do.
Yeah, I agree with that, because I did some radio before I got into TV too, and with doing the traffic and weather channel, Bill, for the longest time, that was voiceover. You had to talk, you had to really tell a story. And Pat, you're like basically the long-standing master of radio. I mean, how did you do it in terms of communicating without a TV, without graphics, and just telling the story? How did that work?
I consider myself very similar to Bill, because I used to watch Bill and listen to Bill, and I always felt that Bill was a very good conservative forecaster, never ever pressing panic buttons, alarming people, bringing the forecast to people, what they want to know, cold facts. How is it going to be for the kids at the bus stop tomorrow morning? How is it going to be to pick up your kids after school? You just have to relate to their life and come up with, I really, really think, the easiest kind of weather forecast without throwing too much junk into it. I mean, I'm not going to name anybody, but I watch several TV people now, and to me, all they do is alarm. We have a special type of day. We have whatever it is, a red colored day. We have a blue colored day. I mean, and they're talking 4 or 5 days out.
Yeah, I noticed that a lot. And I'd say Bill was notorious for being conservative and always being careful about not going overboard on certain situations until we absolutely knew it was going to be the case. And I learned something from one of my professors, Mike Landon, up at SUNY Albany. He said, don't ever forecast a record beyond 48 hours. There's a reason records exist, because they're rarely broken. And you learn your lesson the hard way sometimes. You see a big blizzard coming, and we learned that in March 5th, 2001, with the bust, and everyone was going 2 feet of snow, historic, and it really didn't happen that way. We've seen that happen a lot. I think that level of experience that all three of us here have seen plays into the strength of why TV and radio meteorologists are still valuable to this day.
Yeah. I wish I kept track of all the times I was wrong. I'd fill a book, but I was right more often than I was wrong.
So Pat, where do you see us going? I mean, obviously, we're sort of at the end of our careers, but with the newbies coming in, the new meteorologists, what advice would you have for them with all the technology, everything you have that they never experienced back in the day? What would you tell them?
I would have to say, again, picking up where Bill left off, you have to be able to plot. If you're not going to plot, just track your weather. Watch it, absorb it, and track it, and you should be fine. Although with AI, I have a feeling things are going to be changing a lot more.
Bill, yeah, I agree with that. And Bill, you've seen that too, right?
Yeah, it'll never be perfect. There's no way you're ever going to get a perfect weather forecast, but it's getting better and better and better. And it's important now because so many people are vulnerable. Once upon a time, we were self-sufficient. Here on Long Island, you had your animals and your vegetables growing in your backyard back in the 1700s. Now, if storm hits, you're stuck, whatever you have in the house. So weather's critical, and the forecasts are getting better and better and better. And the younger people today, if they see the changes over the next 30 years that we've seen, who knows how good the forecasts are going to get around here.
All right, terrific discussion. Thank you very much. This is fascinating and important, and I think critical for everyone to understand, what meteorologists do, what we do, what we've been through, what we've seen, and where we're headed. Because the next big Sandy, the next big hurricane, the next big snowstorm, the next big anything is coming from somewhere, and we'll be ready. Thank you both. Terrific discussion today.
It's been fun.